We have finally discovered the actual method used by the ancient Egyptians to cut granite, overcoming the theories and guesses that have circulated among Egyptologists for a century. The definitive proof did not emerge from an archaeology laboratory, but from a scanning electron microscope in a tribology research center. There, Dr. Masoud Karb, a materials scientist with no prior experience in Egyptology, analyzed the surface of a 4,000-year-old granite block and found something unexpected: corundum. This mineral, which is essentially aluminum oxide, is the same mineral that forms rubies and sapphires, exhibiting a hardness of 9 on the Mohs scale and surpassed only by diamond. Because it ranks just below diamond at the top of the strength scale, aluminum oxide is still widely used today in the manufacture of extremely durable and effective tools for cutting hard materials. The mineral was deeply embedded in ancient cut marks, defying the expectations of Egyptologists who predicted finding only sand and copper residue. This unique discovery shattered decades of academic skepticism, presenting proof of a mystery that had remained unsolved. While limestone pyramids are widely understood, the real challenge for engineers and stonemasons lies in granite. With a hardness between 6 and 7 on the Mohs scale and composed of highly resistant minerals such as quartz, feldspar, and mica, granite is so difficult to manipulate that, even with current diamond-tip technology, the process remains slow and complex. Despite the material's extreme resistance, the ancient Egyptians manipulated it with impressive ease, almost as if it were clay. A notable example is the King's Chamber inside the Great Pyramid, composed entirely of granite blocks weighing over 70 tons. In the Valley Temple at Giza, the immense granite pieces exhibit such a perfect fit that it is impossible to insert even a razor blade between the joints. Furthermore, statues carved from single blocks possess such refined details that they suggest the use of machines, while samples from drillings at archaeological sites reveal spiral grooves in the solid stone, indicating drilling speeds that leave modern engineers perplexed and without explanation. Chris Dunn, an engineer with over 40 years of experience in precision machining, personally examined granite artifacts from ancient Egypt. His reaction was visceral. He said that the tolerances he was observing, flat surfaces with variations of only thousandths of an inch over several meters, perfectly circular holes throughout their depth, were not just impressive, they were industrial. He stated that he had spent his entire career surrounded by CNC machines and high-precision components, and that what the ancient Egyptians achieved in granite equaled or even surpassed modern manufacturing standards. Not approximately, not crudely, but with absolute precision. So, what was the official explanation? Copper saws with sand as an abrasive dolerite hammers, and a lot of patience. But here's the problem. Copper has a hardness between 2.5 and 3 on the Mohs scale. The quartz present in granite has a hardness of 7. When you try to cut a harder material with a softer one, even with abrasives, the tool wears down before the stone yields. Dennis Stocks, from the University of Manchester, spent years testing copper tools with sand on granite under controlled conditions. Progress was measured in fractions of a millimeter per hour. The copper wore away quickly. The cuts were irregular and rough, nothing like the old surfaces. Stocks himself admitted that the experiments raised more questions than answers. The dolerite hammers work, but at an agonizing speed. Shaping even a small granite surface by percussion takes hundreds of hours. Scale that up to the King's Chamber, and you'd need millions of hours of work just for the granite. And none of these methods account for the precision. Flat surfaces with minimal variations, perfectly circular holes throughout their depth, straight and parallel cuts for meters. This cannot be achieved with stones and soft metals. For 40 years, Graham Hancock repeated this. The physical evidence doesn't match the conventional explanation. Something is missing. And traditional archaeology has always responded the same way. Hancock is untrained. His theories are fringe. His questions don't deserve answers. Ignore him until he found what was missing. And what he found next is why you clicked on this video. The discovery. Now, this is where things get even more impressive. In 2022, Hancock partnered with Dr. Masoud Karb, a specialist in tribology, the study of friction, wear, and lubrication, at a leading research institution. Dr. Karb had no interest in the debate about ancient Egypt. He was a rigorous scientist facing a difficult problem. They obtained permission to examine Egyptian granite artifacts using scanning electron microscopy and energy-dispersive X-ray spectroscopy, instruments capable of revealing surfaces at molecular levels invisible to any optical microscope. Dr. Karb began his analysis expecting to find exactly what Egyptologists had always described: particles of sand, copper residue, the chemical signature of brute force abrasion that had dominated the narrative for over a century. But that's not what he found. The wear patterns were wrong. The scratch marks didn't match the sand. And when he isolated what was actually embedded in the 4,000-year-old grooves, he stepped away from the microscope and called Hancock into the lab. Corundum. Hardness 9 on the Mohs scale. Harder than any common material in the natural geology of Egypt. Modern industry uses synthetic corundum every day to cut the strongest materials known to engineering. And there he was, in the cuts made even before Rome existed. But here's the crucial detail. Corundum does not occur naturally in Egypt in forms suitable for industrial use. The closest sources are in regions with which ancient Egypt maintained trade routes. But recognizing the properties of corundum and deliberately incorporating it into abrasive mixtures is not something that happens by chance. Dr. Karb was categorical. He explained that using corundum effectively requires an advanced understanding of mineral hardness. Systematic experimentation is necessary. It needs to be ground into specific particle sizes. This wasn't improvisation. This was materials science. If you've been following along this far and this is changing everything you thought you knew about the ancient world, subscribe to the channel. We explore stories like this one, which challenge the official narrative with real evidence. The implications were immediate. If the ancient Egyptians were deliberately obtaining corundum from distant trading partners, processing it into calibrated particles, and mixing it with abrasive compounds, then they understood materials science on a level that traditional Egyptology never considered. But a microscopic discovery is evidence, not proof. Hancock knew that, and she knew what she needed to do next. He needed to replicate the process, the experiments. In early 2023, Hancock organized controlled tests in a workshop with granite blocks, copper tools, and 3 different types of abrasives. He brought together stonemasons and materials scientists working side by side. Sand, the conventional theory; quartz powder, slightly harder, available in ancient Egypt; and an abrasive mixture with corundum, the new hypothesis. And pay attention. The results left no doubt. Copper with sand, 0.5 millimeter per hour. Extremely slow. High wear of the copper. Irregular surfaces. Copper with quartz, about 0.8 millimeters per hour. A little better, but still far from the old precision. Then they moved on to a mixture of corundum and quartz. More than 3 millimeters per hour, 6 times faster than sand. The copper tools lasted much longer. The cuts were smooth, clean, and precise. And the drilling. That was the part that left everyone speechless. It produced samples with spiral grooves identical to those found in the drill cores of ancient Egypt. The same grooves that baffled engineers for decades. The same grooves that the copper and sand theory never managed to reproduce. Right there, on the workshop workbench, freshly cut from modern granite using ancient methods. Nick Giza, an experienced stonemason with decades of experience working with granite, described the moment. He said everything changed. The copper stopped fighting against the granite and started guiding the abrasive. The cut became smooth, the speed increased, and tool wear dropped dramatically. He stated that, for the first time in his entire career, being in that workshop observing ancient methods working on modern stone, he was able to see how the ancients truly did it. But that's not even the most impressive part. The experiments revealed that the abrasive mixture with corundum required real skill. The mixture needed to maintain a precise consistency. Too runny, and it would lose cutting power. Too thick, and it would clog the groove. The pressure needed to be uniform, the temperature controlled. Every variable mattered. This required highly skilled artisans who understood their materials on an intimate level. People who had refined techniques over generations, passing on knowledge from master to apprentice. Exactly the kind of skilled labor one would expect from a civilization that built the pyramids. 3 independent lines of evidence: microscopic analysis, experimental replication, and materials science data, all pointing to the same conclusion. But Hancock knew what was coming next. He had been through this before, and what happened afterward proved that the biggest obstacle to understanding ancient Egypt is not a lack of evidence. It's the people who refuse to look at them, the gatekeepers. Hancock presented his findings at a materials science conference in late 2023, not an archaeology conference, but in a room full of engineers, physicists, and materials scientists who evaluate evidence on its merits. The response was largely positive. Dr. James Harrell, who has studied stone quarrying in ancient Egypt for decades, observed that abrasive mixtures do not preserve well in the archaeological record. Traces of corundum embedded in cut surfaces may be the best physical evidence we will ever be able to recover. Now, this is where things get uncomfortable. When the results reached mainstream Egyptology, the reaction was divided. Some archaeologists acknowledged that the hypothesis was plausible and raised legitimate questions. How much corundum would be needed? Is there evidence of trade in this mineral during the relevant dynasties? Could the traces be from later contamination? Good science asks these questions, but a significant portion of the academic community didn't even analyze the science. They analyzed the name, Graham Hancock, the outsider, the man who wrote Fingerprints of the Gods, the one they spent 40 years calling a pseudoscientist. Their position was clear and direct. Hancock's involvement invalidates the findings, regardless of their scientific merit. The data didn't matter. Replication didn't matter. The name in the study was enough to disqualify it. Hancock addressed this in a 2024 interview. He said that Egyptologists claimed that even if he were right about the corundum, he shouldn't be the one to say so, that his lack of formal training disqualified him, even working alongside accredited scientists with reproducible data. He said it was never about the truth. It was always about control, and this reaction revealed something deeper than any mineral trace. The resistance was never about evidence. It was about authority, about who has the right to rewrite the history of human civilization. But evidence doesn't care about credentials, and the corundum hypothesis is gaining traction where it really matters, among engineers, materials scientists, and a growing number of archaeologists willing to examine the data, regardless of who presented it. What does this really mean? Let's be clear. The discovery of corundum doesn't validate all the ideas Hancock has proposed. His broader theories about lost civilizations remain debated. But on this specific issue, how the ancient Egyptians cut granite with a precision that impresses even modern engineers, the evidence supports the challenge he raised. Here's the point. If they deliberately used abrasive mixtures based on corundum, that completely rewrites their technological profile. They understood the hardness of minerals on a level far beyond what any Egyptologist had assumed. They maintained long-distance trade networks to obtain industrial materials that were unavailable in the Nile Valley. They developed processing techniques, grinding corundum to ideal particle sizes and preparing mixtures with precise consistency, something that clearly falls under the umbrella of materials science. They weren't primitive, they were brilliant, and they'd been waiting 4,000 years for someone to notice. And the discovery of corundum raises a question that should keep any archaeologist awake at night. If we let this slip by, an entire abrasive technology hidden in plain sight on surfaces examined by thousands of researchers, what else did we miss? How many ancient techniques have been dismissed as impossible simply because no one used the right tools to investigate? In a tribology laboratory, Dr. Masoud Karb examined the microscopic image of a cut made in granite more than 4,000 years ago and saw corundum where no one had ever looked before. Inside a workshop, Nick Giza demonstrated that a copper blade combined with a corundum mixture cuts granite quickly and precisely, replicating what likely occurred in the Pyramid era. Graham Hancock, after 4 decades of being discredited and ridiculed by academic institutions that ignored his questions, finally presented irrefutable physical proof. Through materials science and experimental replication, validated by independent experts, it was confirmed that the ancient Egyptians used corundum-based abrasives. This discovery reveals a sophisticated technology that required mineralogical expertise, trade networks to obtain rare resources, and techniques refined over generations. Instead of being limited, they proved to be masters of their environment. If Hancock was correct on this point after 40 years of academic denial, it opens up questions about what other historical facts may be being misinterpreted. The evidence of corundum in granite transforms our view of the past and signals that new mysteries are yet to be revealed.